Last time on Pepes World.
What the hell's the point in all that? It just takes me to the same place. And where's my bike? I guess I have to take the bus. This isn't where I live. Fuck. There's got to be a better way. I'm gonna cheat. In fact, I already did cheat. I've actually done like all of this already. So rather than me like making it and like telling you shit like as I'm doing it, I'm gonna like show you clips from the past, and I'm just gonna like narrate over it and tell you the story. The story of how Pepe made a machine to beat Stacker. Okay, so what the fuck is Stacker? Stacker is a game where you have some bricks and they scroll left to right, and you got to just hit that one button, and that stops the bricks from moving left to right, and it just gives you some more bricks at one row up, and you got to press the button again to stop your bricks on top of your old bricks, and that builds up a stack, right? And it goes higher and higher and higher, if you're good enough, and it gets faster and faster, but you can't really get to the top because it's just too fucking hard. Some people can do it, but not me because I'm slow. Now I fucking knew that I would just need something that would smash the button really quickly and a computer to sort of figure out the game, right, with a camera there. Now I tried using fucking computer vision, right, and I got some cool algorithms and things, but oh my fucking god, it was so fucking convoluted. Getting the laptop set up and 5 FPS and all this sort of shit. Then I realized I could intuit this entire fucking game just by one pixel. Because really, you just need to look to see if like that one pixel in the middle was on, and then just hit the button real fast. And Arduino could do it. So I needed a light sensor, right, that looked straight forwards, not to the sides, right? And I tried various things. I tried initially with a fucking just a photo diode from a nightlight shoved inside a pen. This didn't work at all. There was like fucking, it was like the sensor took like 5 fucking seconds to adjust, and the field of view was just like fucking enormous. But I got myself a better light sensor, one that's basically like in the same chassis as an LED. That's not the right word, is it? But who cares? And a drinking straw is the perfect fucking fit. So that's what I went with, and that worked really fucking well. But there was some more problems. For starters, the inside of a drinking straw is just it's all shiny reflections, right? So light that's coming in from the sides is going to bounce off the walls and then eventually touch my sensor. But au contraire, we can fix that. So what I did is I got a paper straw, right? And I painted the inside black, and then to rough everything up, while the paint was still wet, I poured salt down it. That's right, motherfucking salt. And that stuck to the walls, and then I painted it a little bit again, and before you know it, I've got a rough interior. Ooh. So, hitting the button. All I have to do is just hit a button, right? So you think, oh, well, solenoid. Well, not so fast, young cowboy. A solenoid, whilst simple to use, it's actually not very straightforward to use precisely. For example, that steel rod, as it goes closer into the magnetic field, it gets more and more power. So the torque is non-linear, and that's not really easy to work out when you've got to hit a button at a specific place and at a certain time, and you don't know ahead of time like how springy that button is. It's just a fucking nightmare. It's just crap. Now I tried to remove variables by say holding the thing down really steady, just giving it shit tons of power, like shit tons of batteries, like using up all of my 9-volt batteries, and that it just wasn't, fuck off, it was just shit. And that's when I thought, I need precision, right? So that means, well, hey, stepper motors, right? You can precisely control where they go. But what about specific dimensions of that button and such? I needed specs. So I emailed the vendor of Stacker, LAI Games, and said that I needed specs on this machine. My excuse was that I wanted to make button pressing rigs to help disabled people with their motor skills, which, when you think about it, isn't really entirely untrue. Fuck! Alright, so... Whoa! Hold on to your cocks, it's mail! But I didn't really get anything from them, as you can imagine. So then I went down to the arcade and I took a mould of it using tinfoil. And I took the tinfoil home and filled it with hot glue and stuff, and I worked on that for a while. But that was shit. The button didn't even go down, it was just like the worst action figure toy in the world. Haha, I even tried photogrammetry, man. Dude, that was fun. But eventually the people on Queen Street gave me enough change to buy a couple of spare part buttons from a spare parts merchant. Now getting precision like this was a little bit beyond my arts and crafts skills, so that's why I stole a 3D printer.
Christ.
I opted for a pretty simple design with just a direct drive. I didn't want to deal with gears or any bullshit like that. But because it's a stepper motor, it needs a point of reference for all of its coordinates to make sense. Now I figured the top of the button would be a good place to take a reference from. But how does the machine know that it's touched the top of the button? Well, au contraire. Piezoelectric transducers. That's right, these little bleepy things that you would use in your electronics projects for a microphone or a crappy speaker. Well, if something bumps into it, it creates a voltage. So this thing does a couple of test moves, and when the piezo transducer bumps into the top of the button, sends a voltage out, and the ADC grabs it. Whoa, we've got our reference point, motherfucker. But how far do I have to push down this button for it to make electrical contact? Well, it turns out, for every button, it's the same every time you push the button, but if you change buttons, then it's a different value for that button. We'll see later that this comes back to bite me in the ass really fucking hard, and even just putting like calibrations for like millimeters and stuff doesn't fucking help. But we'll go off and take a quick piss break, and then we'll come back and we'll work more on the optical unit. University. Do you find it difficult to learn at university? Me too, but that's because I'm retarded. What's your excuse? University's got plenty of resources for free. And it also has a great culture. Oh, come back. Asshole. And now that it's the future, there's all kinds of interesting stuff, like robots and things. Say something. So while it might be easy and fun to learn off YouTube and stuff, don't knock university. It's fucking good. You're just gonna make good life decisions. But of course the light scope that I was using was still kinda sucked. It wasn't really precise enough. But hey, I've got a 3D printer now, let's make a fucking better one. But then I realised, this has already been made before. The fucking Nintendo light gun. Fuck yeah, this thing looks at a dot and it's really fast and it only looks in one direction. That's just what I want. So I got some cheap knockoffs off eBay, and it turns out that the lens inside, well, the cheap Chinese manufacturers actually put the light sensor in the wrong place. Don't know what the fucking deal is with that. Hey, pro tip, if you want to see what the field of view is of a light sensor, just shove an LED in there instead. That's awesome. And in addition to being awesome, it's actually really helpful. You can see here in my design, the white light there is actually smaller. Means there's a narrower field of view. Means I improved the design. Fuck yeah. But what about the actual lights themselves? How big are they? How bright are they? Well, I could sort out the size of the things pretty easily, but I couldn't really determine how bright they were. So even though I'd made a little mock-up of these lights which I could test, I didn't know if they were too bright or too dim. So I reached out to the community, and guess what was happening again this year? They brought back KiwiCon! Fuck yeah! So I actually thought, hey, I know, I'll submit this to KiwiCon. And lo and behold, it was accepted. Oh balls. So I was asked if there's anything I needed, and I was just like, maybe some of the actual lights from the machine. And fucking Bogan from KiwiCon, he actually fucking paid for some real lights from the machine. Like, I got some from a spare parts merchant. Holy shit! What a fucking hero! I love KiwiCon. Yeah, okay, so we've made a sensor box which can get the light from only one of these pixel sets going on or off. But how do we tell if it's on and how do we tell if it's off? We've got this analog voltage level going into the ADC, right? But we need some smarts to convert this to a Boolean. Now, I initially thought, I know, I'll just record the brightest value and the darkest value. Sure, that's straightforward, and if it's nearer to the top or nearer to the bottom, then we're good to go. But there's all these problems. For example, the light isn't always the same value, say, when you go to the next light, and then the next light, and then the next light as you're playing the new levels. And you have to recalibrate every time, and that's bullshit. And noise was the problem as well. Is it like up to like, if there's thermal noise, do I make the threshold at, say, 90% of the full brightness? And if that's the case, then sideways light could fuck it all up. It's just atrocious. But that's when I got a better idea. Now let's say you're in a room with a light, and you've got a light switch. You turn the light on and you turn the light off. You know that when it's on, it's always going to be brighter than when it's off. And you know that when it's off, it's always going to be darker than when it's on. Now, what if you turn the light off and on really, really fucking fast, and you got an average of that? Let's just say it was 50%. You know that when the light is on, it's going to be brighter than that average 50%. And you know that when the light is off, it's going to be darker than that average 50%. Now, as it turns out, you turn that light switch on and off in any speed you like, or in any proportions you like, say 30% on, 70% off. You pick anything you like, and when it's on, it's always going to be brighter than that midpoint that you choose from averaging it from your flickering with the light switch. And when it's off, it's always going to be darker than the average of whatever patterns you've been making with flashing on and off the light switch. So the idea was to keep a rolling average in memory of the last, say, 3 or 4 seconds, and constantly ask every microsecond or so, is the immediate value coming into the sensor above or below that average? And it turns out for any fast repeating pattern, this works extraordinarily well. You don't even have to calibrate it. You just need to make sure that it's fast enough to keep that average in the right place. Okay, so I needed to have a really, really, really huge pull-down resistor in order to get high enough impedance to get a good signal out of this light sensor, which unfortunately brings lots of thermal noise and garbage. But you can fix this, right, by oversampling. Well, I used a faster Arduino, the 84 MHz ARM one for starters. But of course, any scientist who counts photons is looking at the screen right now and saying, what the fuck is this guy doing? There's no amplification here. He needs what's called a transimpedance amplifier. What the fuck is a transimpedance amplifier? And why do I want to use it? Well, we want to be converting the current output of a phototransistor into voltage. Now, why do we want to do that? Well, typically the output of a phototransistor is much more linear with the current output, believe it or not. And also with a high feedback resistor, the transimpedance effect of converting current into voltage actually increases linearly. However, the noise only increases with the square root of the feedback resistance. That means you get a much better signal to noise ratio, which is exactly what we want. And believe it or not, I have so much fucking gain that I can actually point this right at the lamp and see the mains voltage waveform. You're looking at the mains through light from the lamp. How awesome is that?
Baby's gonna show you some theory.
But you know, if I'm going to record 4 seconds worth of light, that's a huge amount of data to keep inside the memory of one of these little microcontrollers, right? Even one of these bad boys. And even if I did have the memory, it's just too much to iterate through every time on my main loop. So, what do? Wow, riddle me this, Batman. Damn it, there's a fucking plane outside. Shut up, plane, I'm trying to record. Anyway, if you look at all of these samples, right, and you split them into 2 groups, if you get the average of group A and the average of group B, well, you got two values there, right? If you average those 2 together, that's exactly the same as the average of the whole fucking lot. Now, it's a lot quicker to just average 2 things together, right? So that's where I got the idea of just making these buckets. Of course, this is all just fucking bullshit, right? I don't need to have 4 seconds worth of samples to get the average of the last 4 seconds. All I need to do is what's called an exponential average, which is where I just simply take 10% of the current sample and add it to 90% of the last sample. So what you end up doing is you just keep having this rolling accumulated average where the new sample only affects the current count by 10%. And that makes smooth, gradual changes. And that, of course, is the average smooth line for me to compare my current sensor value to. Awesome. Now that we have the ability to digitally tell if a light is on or off, we need to know ahead of time when the light is going to be on, because in case you hadn't noticed, the step motor moves really fucking slow. However, if we're just looking at one light at a time, well, the repeating pattern that we would see isn't just a simple on-off pattern. There's complexities involved because it's off for most of the time. So what we need to do is we need to record the timestamps of when the light is on and then when it turns off. And then it's just a case of using mathematics to predict when it's going to turn on again in the future. And by connecting the stacker light directly to an interrupt pin on the Arduino, I could tell that the photo transistor had a delay of about 2 milliseconds. Like all the best farts, there was a random component to the delay of this light sensor. It was about 300 microseconds or so. And my approach of recording these small time spans of a couple of milliseconds, say 5 or 6 of them, and then stacking them together in order to predict a time in the future, would actually accumulate 5 or 6 of these 300 microsecond fuck-ups. And that was bad news. So what I realized I could do was actually record the time delta between very distant time events. That way the 300 microsecond variance was actually fuck all in relation to the actual time span I was measuring. That way I could actually divide down to calculate the length of time that the light was on or off for. And that way the random 300 or so microsecond variance was divided down and became fuck all. And that's a fundamental that applies to lots of fucking things. So put that in your pocket and take it home. Oh, is there a birdie up there? Well, Dad's got the optical unit working. Let's go work on the button pushing machine. I love how playing with batteries is so safe because you can't get zapped. Now, really what made this project take so fucking long was that the stepper motor took fucking long. It seemed like the stepper motor was the golden ticket for consistency. But after hitting my head on the bench, I realised something really fucking crucial. And this is key. John Key. A stepper motor only really gets its consistency from being a really overpowered coil. It just uses pure muscle to be precise. And there's an upper limit to how fast you can make a stepper motor really turn before you oversaturate those coils and you burn it out with too much voltage. And that button on the machine is different from mine at home. It's fatigued from lots of use, so I don't know how far down to push it to make electrical contact until I'm there. And even then, every time I press it, it's different microscopically. And because I can't speed up the motor, those little micro differences translate into several milliseconds.
They're totally aware of what we're doing, by the way.
Are they? Oh no. But surely only the very last tick of that step motor as it connects the electrical circuit is the only one that needs to be on time, right? All of the previous steps weren't influencing anything, so why would they need to be on time? So I'm finding that I only give a shit about one tick from a step motor that only gets its precision anyway from being a high-powered muscle coil. This means without even realising it, I'm simply dependent on a solenoid. Oh fuck! So I'm back to the solenoid approach. But I've learned something. I've learned how to make it consistent. And the answer is more fucking power. Fuck. This time, I'm much smarter at electronics. I'm not relying on pussy 9-volt batteries, but rather a boost converter which is supplying a huge capacitor bank which dumps all of that power into that solenoid all at once through a low RDS on MOSFET. And I think this adds up to about, over 100 watts to maybe half a kilowatt. Fuck. It sure fucking felt like it when it squished my finger. Fuck. But you know what else it felt like? It felt consistent. 5 milliseconds consistent. Mwah. Now the cable itself between the optical unit with the brain and the actual button smashing unit was actually really fucking me off, so I replaced it with a simple radio transmitter and receiver. It's a story for another day because it had some really weird interference problems, but the way that I've programmed it is that it has a maximum of 2 milliseconds delay, no more. So what does it all add up to? Well, if you add the radio delay to the solenoid delay and to the known delay of the optical unit, well, that's 10 milliseconds. And that means, even without preempting anything, If a light stays on for longer than 10 milliseconds, we'll be able to whack the button on time. Holy shit, that's 100 FPS. And as we'll see later, the real machine down at the arcade is nowhere near that fucking fast. So even though our machine is looking for a repetitive pattern and then locking on and preempting when it's going to appear again, if the light appears too early, then the machine is going to be able to detect that and hit the button in time. And if the arcade machine fucks with us by making the light appear too late, well, we'll see that, right? And then we'll be able to point at the machine and go, ha, look, you're fucking lying. Now that we know we can play the stacker game at 100 FPS, how fast is the real stacker game? I shoved a high-speed camera in front of that thing, and the light was on for a whopping 71 milliseconds, with a margin of error of 4.8 milliseconds. Now how did I get that 4.8 milliseconds margin of error when my camera is only 60 FPS and each video frame takes 16 milliseconds? That 16 milliseconds margin of error, right? Well, I get hit with that twice if I'm trying to figure out the start and stop of a light flash. That's like 30 something milliseconds margin of error. What? How does this work? Well, look in your pocket and check out that fundamental I gave you. You see, this game has got 7 lights, right? So what I did was I measured the start and stop time of all 7 lights together as one. And that way, the 30 something millisecond penalty was for the whole 7 lights. So if I divided down to calculate how long one light was on, my margin of error was divided down as well. Of course, this assumes that all of those lights are going to be on for an equal amount of time, right? So, ignoring the magic, I just recorded how long the light in the middle was on for, knowing that I had this margin of error of like 33 milliseconds. I measured the light staying on for 66 milliseconds, so with the worst case scenario, that makes it 33 milliseconds that the light was on for, and our machine can handle that while drinking a cigar and smoking a whiskey. So now that we're certain of the limitations of our machine, and we can prove that our machine can play stacker well in excess of the speed of the real arcade machine, let's go down and kick its ass. Goddamn motherfucking son of a bitch, fucking shit, cunt, asshole, fuck dick, fuck cunt, ass. There's not enough throw. Fuck. Okay, so the real machine has been fatigued from lots of use, so it has to be pushed down a little bit further to make electrical contact. I'll just have to go in and like 3D print like a little millimeter extra for the thing or whatever, but we'll come back and it should be fucking good to go, right? Fucking thing. I don't know how fucking fatigued that button is, but even with the extension I put on the end of the solenoid, I still had to put a little credit card underneath there just so it had enough throw to push the button down. I wonder how this affects the timing, although to be fair, it's pretty bang on from what I can see. Oh my fucking god, I have to go kill somebody. Oh my god, I'm gonna get put on a list for whatever I do next. Oh, hang on. No, wait a minute. I know my hardware is good. This arcade machine's the fucking liar. Asshole. But I still feel like I was on the tail end of that light event. I'm gonna set this to be 30 milliseconds ahead of the clock. Remember, the optical unit can see this game, and it knows that it's 3 milliseconds behind the clock, and it knows to factor that out, and it knows to preempt when the light's going to appear. And even with the radio unit and the solenoid delay as well, we know how fast that light has to move in order to be too fast, and we know it's nowhere near fast enough.
Oh, so it's too late?
Oh, and the game just told us that we're too late, even though that we're 30 milliseconds ahead of the clock. I smell bullshit. Okay, Okay, so now I've set it to be 40 milliseconds ahead of the clock. Oh, fuck off, mate. No fucking way. I'm going to set this to 50 milliseconds early. Now, it kind of bugged me that I couldn't quite see on the video that the solenoid was hitting much earlier, and I didn't really program on my machine for it to tell me if it really did see that the light was too early or not. But with the virus fast approaching New Zealand, I couldn't really afford another visit to the arcade. But if you're looking at the same footage that I am, I think you can see that that's hitting on time. Yeah, I played this for a couple more goes, but I started to see how this machine was fucking with me, right? You see, that repeating pattern my machine did lock onto. If it was honest, my machine should have been 50 milliseconds ahead of the clock, but it wasn't. It was just bang on. So if my machine caught an early light flash which it couldn't have preempted by 50 milliseconds, well, the machine's physical delay is the same every single time. So we should have seen the same failure every single time, but we didn't. We saw something random. So, would you call this a win? A loss? I don't know. If I keep playing this again over and over again, would I eventually win? Well, yes. Do I want to waste all that money? No, because gambling is stupid. If you're in a position where you have to gamble, cheat. Am I potentially gambling that somebody is going to find the firmware of that machine and prove that it was or wasn't fucking with people? Well, no. I'm applying a mechanical and creative process to reduce uncertainties. Science. And although it looked like I was playing a machine, that machine was trying to play me for a fool. And through science, I didn't let it beat me. Now, this is really a story about turning a loss into a win. Do I really care about winning a prize in this machine?
No, I don't give a shit about that. It's all about beating that fucking machine, right? You see, like, I learned all this crazy shit along the way that I never would have thought of looking into before. You know, like, I learned all this really advanced Arduino shit with, like, you know, interrupts and asynchronous ADCs with DMA and shit, you know. I learned about, like, light sensors and optics and, you know, lenses and fluting and transimpedance amplifiers and shit, you know. I learned stepper motors and lead screws and how 3D printers work and all that kind of shit. And to like make all these models and things, you know, like I had to learn how to do computer-aided design. You know, fucking this shit was like new to me. Fucking you know, but I tell you what, it's no secret that, you know, like I felt pretty shit after a while, you know. You know, learning all this stuff is worth like 1,000 fucking times more than like some stupid little fucking iPod Touch. I don't give a shit about that. It's all about the wisdom, right? And not just wisdom about what works. It's about what doesn't work. And that's fucking so much more worthwhile. You know, like all these crazy things, you don't know why they work. You know, you don't know until you try, right? And I've learned like all these things that would, you know, if I knew how this worked at the beginning, I never would have known all the surrounding shit. And I've learned fuck tons, right? Now I'm really fucking powerful. I'm like 10 times as powerful as what I was before. So you know what? If you feel like shit, just stick at it. It's worth it.
This episode of Pepes World was brought to you by Squarespace. If you find it difficult to make websites, then you can fuck off. No, get fucked. And this has been another episode of Pepes World, the show for computer hackers with no money and no friends.
Raspberry Pi, Arduino, YouTube, 3D printers and drones. Like, share, and subscribe.